Okay guys, sorry for the delay of game. Apparently my camera will only record for 30 minutes and I was blathering on forever. And for those of you who are still stuck with me without hitting the fast forward, I don't know why you haven't hit the fast forward already. Either way, effectively all I've done is I've cut the adhesive on the back because the adhesive is a constant strip, and then I desoldered this using the methods that I've shown already before, where you just add a little bit of heat to one side and bend it away, and as these joints melt, the stress will generally cause this thing to start to loosen up. Eventually you'll get it breaking free just by just gently putting a little bit of heat on each one of these to reflow the solder, and it slowly works itself free. Okay, so we're still stuck here where we've got a single little bitty strip here that when we plug it in, it now works. It used to work with the whole thing, that's why we cut it. Now, here's where this guy comes in. This controller simply does not know one color from the next. It's red, blue, or green to us, but for it might as well be channel 1, 2, or 3, or A, B, C. It just simply doesn't know. All it's going to do is just pick one and give it. This guy will take the channel coming from this strip and will make sure it does not map one for one here. In fact, it maps it in a very specific order. It's called a roll. So if we have GRB here, what I'm going to do with this guy is he's going to make sure that blue gets mapped up to the first position. So on this side, it will be BGR. So when this strip is blue, this strip will be green. Kind of cool. Anyways, so first things first. A little bit about the layout and the lines on the pin on the chip itself. I'm going to have to rework the artwork on this thing. It just came fresh off the foundry, and that was a mistake. I was really hoping that it was a misrender, and nope, they were rendering it right. This strip marks that this is a continuous. So here to here is continuous. These two pads are connected together. And that's good because we want the 12 volts to continue through on the strip. So 12 volts is connected to 12 volts. It's the grounds that we want to scramble. And so we have green connected to red or blue and so on, so that they're never really mapped to the same ones. That way I'm guaranteed that the strip on this side will have a different color than the strip on the other side. So what I'm going to do is I'm going to go through and I'm going to so this mark tells me this. Now this mark is telling me the direction that it's going to roll. So it's going to take this pin and move it up here. So as the current goes across it like this, it's going to roll up. Now what if I wanted it to roll down? Because, well, you know what? Maybe I want the colors to change the other direction. So if it's blue, I want it to change to green, that's fine, that works here, but what if I wanted to change it to red? Flip it over onto this side, and now you notice that the arrow is going, the line is going the other direction. So the green line is now going to blue. Well, the other side of that is, as it's going across this way, the blue connector here is now going to red. So this is how this thing is used. You can either get it to roll up as the current goes across it. So as the current goes across this way, the current rolls up, or the current rolls down the channels. One way or the other. So, first things first, just for sanity's sake, make things a little easier on myself. These pads that come from OSH Park. OSH Park's a great service, it's wonderful, but the type of lead finishing that they do is these goldish pads, and these goldish pads are not tinned. You really do have to pre-tin them to use them. And I do need to clean my tip just a little bit more. Okay, so it's really just kind of that easy. Flip it over and look on the other side. It is quite hot right now, and you'll notice that Whereas here we've got empty little channels right there, and that's probably not going to focus real nice. Over here, the channels are filled with solder. That's kind of good. Actually, what I am going to do is these sides, as you can see, are still a little on the golden side. They are not quite tinned. I am going to coat these with flux, and then lay them on top of the pads over there, and then heat them from above. They will reflow beautifully. Just one of many little bitty tricks. I'm trying to put as little solder as I can on these guys. And the nice part is you can put the iron right in the little crack, in the little crevice there, and it will reflow the solder in beautifully. Ow. One warning, solder is hot. I know. Rocket science there, guys. Just be aware. Solder's hot. Okay. So, we take the tested wire that we know works, and we take this section here. Now again, I need to make sure that the ground goes to ground, or the power goes to power. So this is the power side, this is the power side. This needs to go in a different orientation. This does not work. This will not work. This has to work, or it has to be this way. So the solid slash and future versions of this board, it'll be a wider slash, has to go with a positive line. That's not a negative, that's a continues through. And so I got to decide whether I want it to go up like this and roll up, or get it to roll down. Well, as I said before, I kind of wanted this to roll up, so I'm going to take and I'm going to grab the board by the side there, and we're going to just sort of set it on there, add a little heat, it'll all flow in nice. Before I go too far, because this one can be might be a little problematic. I'm going to take the tin of solder flux that I have, and I'm just going to lightly scrape. I don't need much flux on this. A little dab will do you. And so, a little bit of heat, a little bit of flux, and then I'm going to take and I'm going to, actually, you know what, before I do that, sorry, pardon me, I'm going to reflow these. Because they're nice and flat, they connect up so much better. And so, okay. This is kind of the reverse of what I was doing before, where I was peeling off the connector and trying to use the peeling off action to separate them. I'm pushing against it as the solder melts so that it seats a little better. Not exactly the cleanest, but it does work. If you look in carefully in there, you can see 4 actual good solder joints in there. Alright, so we're going to take and grab it like that. And we're going to connect these in the same manner. Again, scrape a little flux putty onto it. Clean the iron. All right. Now, one thing you'll notice is that I have bridged the solder pads there. That's not necessarily a great thing to do, But again, use the flux to your advantage. Add a little bit more flux, a little bit more heat, and then use the heat of the iron to draw it away from the other pad, and you'll be in good shape. And so I'm going to reach down into the joint itself, and the solder underneath and the solder above are all there. And again, I'm using the reverse of the process I did before, which was before I was trying to peel it away from the pad I want it to disconnect to. Now I want it to reflow into it. And there we go. So, moment of truth. There are two ways I can test this, depending upon how ambitious I am. First is to go ahead and pull out a multimeter and check across here, and following the lines here, these two should be straight through. These two, the B and the G, should be connected together. And if you look, you can see a little bit of where the actual PCB lines are here, and it's really just a rotating option on the colors. So if you move green to blue, these all shift the other direction. So red is connected to green and blue is connected to red across there. Now again, which color is going to become which depends upon the direction of the current flow. So when this one is blue, because it's connected to the actual controller, this one will be green. Just keep that in mind, whether it up or down depends upon that direction of the current flow. And okay, since these are ground, technically the current's going that way, but the power is flowing this way through them, so think of it as electron flow, because the electrons are flowing that way. Anyways, okay, the analogy's breaking down, I don't care. So, the other test, and so notice, I go to fix color. That one's red. Actually, let me go ahead and lower the brightness a bit so it's easier for the camera to see. That one's red. That one's blue. So whenever this one is blue, this one's not red, that's blue, so I'm going to go to the next color. So whenever this one's blue, it rolls up to, hey, look, it's green now. And as I go through the colors, green and red will never be the same. Blue and red will never be the same. Now the trick with this is, because you've got 7 connections there, you can actually roll this or re-scramble it 7 different ways, one of which of course is meaningless because it's the same value. Excuse me, 8 different ways, one of which is the same value, so it's not really scrambled. The problem is only 2 of them, only 2 ways you can change this. You can roll these connections. Will you actually generate a consistent, always, they're different colors, with one exception. They will always be white together. And I've got to actually find white. They will always be white together. Why? Because white is all 3 colors running at the same time. If I do any other separate combination of colors, they will be different consistently. And really, that's kind of what you're looking for anyways. It can look really stunning in flight, and again, you can do 2 different directions. You can roll up or down. And depending upon that, depends upon whether this strip turns from green to blue or green to red. And doing that, you can make one color red, the other, or one wing red, one ring green, and the fuselage blue. That's a very common pattern that I use. I'll set that. But then you can actually go into different modes where you have color changing. Some of the smoother color changing modes get really nice. Some a little more than others. Either way. I hope this has been interesting to you. There's a few other idiosyncrasies and oddities of wiring these up. To do a wing with 3 different colors in it, like a flying wing, in fact, I just did an arrow with these. I ended up having to make 4 of these joints. Now, granted, I didn't use these PCBs. I wired them up manually, taking this kind of cord and scrambling it internally. Which isn't that difficult. This just makes life a lot easier because it's a quick solder joint as opposed to strip, solder, twist. Dang it, I've got the wrong connection. Let's rewire it the other way. You would need 4 of these to do that wing, and that would give you a center fuselage of blue, a left wing of green, or excuse me, a left wing of red, and a right wing of green. So you can get the regular navigational patterns with a blue center fuselage if you like, or all sorts of things. But you would need 4 of these guys to do the wing in that pattern. You start with the center being blue, you transition to for instance, green, you come out the end of the wing, you come back to the center, transition back to blue, so that's a second one. Go to the other side of the wing. You would either need a jumper to go to the other side of the wing or wire it up after the wing is joined. Then another joint to go from blue to red, out to the edge of the wing, back, red, back to blue, finish out the center of the fuselage. You could get away with 3, but it's a little bit more complicated because you have to start in the middle of the strip as opposed to starting in the middle of the wing. It's really up to your choice as to what you want to do. I really enjoy the way these wings look. They come out real nice, and these controllers are dirt cheap, and all you really have to do to add to the party is a little bit of ribbon cable. I mean, if you've got computers or spare scrap computers that you're not using anymore and will never use, there's plenty of these in there for hard drive connectors, a power connector to do this, or a wire that you can wire into the battery harness. I would recommend that you make sure that you check your polarities. I would not feed this reverse biased. It might be protected. I've never tried. I'd rather not. Either way, it's really easy to put these things together. Lots of little bitty steps, but they come out well worth the effort. Either way, take care, guys. Have fun, and thanks for bearing with.